Hello and welcome. My name is Chris Robinson and I am with Nebula Safety and Environmental. What I want to do today is to show you a quality process safety sharing that I've shared at various companies in the past. My goal here today is to provide you an example of a process safety sharing that, if shared with your workforce, including down to hourly personnel, can really help them to understand how they play an important role in process safety management. The sharing that I'm going to share today is the Pennzoil refinery incident that occurred in the year 1995. Now, this refinery is no longer in existence. However, we can still learn from this incident. Before we get started, I'll need to share a brief disclaimer. I have no firsthand knowledge of this incident. Everything that I've learned about this incident, I've gathered from materials that are publicly available. There's a link provided in the PowerPoint slide that goes to that report for this incident investigation. So I've gleaned all the information that I've received from that report. What I'm simply attempting to do is to relay that information such that it can be readily learned by all folks within your organization, whether that's hourly workers all the way up through supervisors and then through leadership. So I hope you enjoy the presentation. Welcome to Throwback Thursday. My name is Chris Robinson, and today I have another safety message to share with you. Today, I'll talk through the Pennzoil refinery incident that occurred in the year 1995. The Pennzoil refinery is located in Pennsylvania, the Quaker State Refinery as it was called. Now, this refinery operated for more than 100 years, but finally shut down in 2001. Despite it being shut down, I believe we can still learn from this catastrophic incident that occurred in 1995. Prior to the incident, there were tanks that were at the refinery that were used for wastewater treatment. These are tanks 487 and also 488. These were not connected to other tanks. However, the tanks did share a dike with the neighboring tanks. I'll talk through the sequence of events. The day of the incident, a hot work permit was granted to begin welding on a service stairway between 487 and 488. After a gas test initially indicated that there were no combustible vapors, they began work. So they were good between 7:40 a.m. and 3:30 p.m. There was a welding crew that was there. There was also a fire watch, and the welder and the fire watch began working together to conduct the welding repair. However, they took a break at 9:30 a.m. after completing some tack welding. When they returned from their break at 10 a.m., they didn't think to go back and conduct a follow-up gas test. Instead, they started work, they returned to work and jump-started the welding machine. Unfortunately, around 15 minutes later, a whooshing sound was heard, and suddenly there was a low boom and flames engulfed tank 487, which you can see on the diagram in the upper right. Unfortunately, a very large explosion occurred, which resulted in tank 487 actually getting blown up and getting displaced some distance away. So you can see the original location of tank 487, and then you can see where it was moved to, which is in red. Additionally, tank 488 also went up and was blown off the ground and shifted from its initial position to where the purple circle is in the diagram. So very sudden event, very significant explosions that resulted in these two tanks being moved, and ultimately the consequences were 5 fatalities and 2 serious injuries. They also damaged many other tanks and contractor trailers that were in the area. So if you flip to the back side, I'll share a little bit about what the incident investigation team was looking into. So on the back side, you can see that there is a diagram that's included in the incident investigation report. This diagram shows the potential sources of vapor that could have leaked during this incident that then found an ignition source. They also weren't able to determine the exact source of ignition. So it could have been multiple ignition sources that could have ignited the source of vapor. For the sources of vapor, they determined that it was possible that there was an escape from the open manway. So when they looked at the manway, they saw that it wasn't vapor tight and that a transfer hose was in place. And so there was potential for vapor to leak around that transfer hose. Additionally, they looked closer at the swing line. The swing line entered the vapor space inside the tank, and the swing line valve was open outside of the tank. So again, there is potential for vapors to emanate from that swing line area. Thirdly, they saw that there was potential escape around the transfer hose. And then fourthly, to their surprise, they actually found holes in the side of the tank. So there were holes up to 1/4 inch in diameter, and these were found in tank 487, which was the first tank that suddenly exploded. For potential sources of ignition, they identified a few. They identified first the welding rod or sparks that were in the area. Obviously, the workers were conducting welding nearby the tanks on the day of the incident. There was the welding machine itself, and then also the electrical arcing from welding or the grounding cables. I think that there are a few things that we can learn from this incident. Number one, when we're conducting hot work out at our work site, we need to make sure that there is no vapor being leaked from equipment nearby. In the case of the Pennzoil refinery in 1995, they didn't do this very well. They were conducting hot work in the area of tanks, and there were multiple potential sources for vapor to be released from those tanks during that event. Unfortunately, vapor was released and it resulted in a catastrophic process safety incident. For our work site, we need to make sure that we use continuous gas test monitoring when conducting hot work, and do this with excellence. Ensure that we are tracking the data and making the right decisions as we progress forward with hot work for critical maintenance tasks. Secondly, we need to ensure that we best control possible sources of ignition. Just because there's a vapor release doesn't mean that there's a catastrophic process safety incident. However, in the case of the Pennzoil refinery, there was. They didn't control their ignition sources well. They had multiple potential ignition sources, and as a result, when vapor was released from the tanks, it found an ignition source, ignited, and resulted in a catastrophic process safety incident. So at our work site, we need to rigorously manage these ignition sources, think about how to minimize them, and reduce the potential for ignition if there is a vapor release. Thank you, and have a great safe day. I hope you enjoyed the presentation today. Again, my name is Chris Robinson with Nebula Safety and Environmental, and I was very happy to share this information with you. As sharing video presentations of process safety incidents can dramatically transform your workforce. You can readily get process safety information that is pertinent to hourly workers down to them. They can understand what it is that they do that is so significantly linked to process safety performance, and they can make sure that they complete those tasks with excellence, whether they are in operations, maintenance, technical, or other groups at your work site. So please reach out to us. We would love to assist you in your journey in improving worker engagement and process safety management. We know that this will improve your process safety performance. So thank you and have a great day.